As we pick up our discussion of network protocols with three major email protocols we're going to discuss here, SMTP, POP, especially POP3, and IMAP, particularly IMAP version 4. And the reason I put SMTP and POP3 here is that I want to really compare the two because they have similar jobs, but they're not the same, and they do have totally different port numbers as well. But I also want to mention to you that you really can't go wrong with email and learning more about how it works in your company or overall with any particular email application. Because when you become an email admin master, you're really as close to indispensable as you can get in this field. Email's not going anywhere. We're always going to have it. And a lot of admins, frankly, don't like to work with email. It's never bothered me. I like the challenge. But a lot of them just don't like, people don't want to do it. And it's true, you can deal with some, picky end users, and it can be, a kind of maddening job at times to be an email admin, and you're nodding your head if you are one. But again, you really can't go wrong with it. The more you know about that and the better you are with email and email applications and setting up servers, really the better off you are. So any experience you can get in that area and more learning you can do, the better off you are. And getting into the details here of SMTP and POP3, SMTP runs on port 25, and it's used really for two purposes. The major one is to transfer email from one server to another. When email is being sent from one email server to another, the Simple Mail Transfer Protocol, SMTP, is in action. Also, when a client is sending mail, SMTP is the protocol that's used to get the mail from the client to the email server. And again, that's all done on port 25. I put a few additional notes up here. SMTP runs at the application layer of the OSI model. And SMTP uses MIME. And if you've seen that in some documentation, you go, what in the world is MIME? This is what it is. It's multi-purpose internet mail extensions. That's why we call it MIME, because it's quite a mouthful. And what it does, it allows us to put graphics, audio, and video into emails. And emails, of course, with too many graphics or too much audio or too much video is the bane of the existence of an email admin. But MIME is what does make that possible. Now, when client software such as, say, I'll name the big one, Microsoft Outlook, is used to retrieve mail from an email server, it's actually POP, Post Office Protocol, that runs on port 110 that is put into action to make that happen. And it's POP3 that is used to download the messages or the emails from the server to the client. And if you're like me, you look at that and you think, well, what happened to POP1 and POP2? Well, those are obsolete. You're really not going to see them around anymore. It's hard to even find any documentation on them. And POP3 has been in use for quite a while. And on occasion, you may actually see some books or some online references that mention just POP or Post Office Protocol. They're referring to POP3. They're not referring to POP1 or 2. Now, this works really well. POP3 has been around for a while. It does play well with others. It's very efficient. But there's one, and there's always a but, right? This is networking. There's one part of its basic operation that was okay years ago, but not really today. And the problem is that when an email message is downloaded via POP3, in most instances, not all, but theoretically, the message itself is deleted from the email server after the download. And on one hand, as a network admin, I love that, because that's going to make sure that my mail server doesn't get overloaded with messages. Because when somebody goes in and downloads 100 messages, POP3 will get rid of them off the server. But, of course, that begets a problem as well, because then you've got an end user later who says, hey, wait a minute, I didn't know that. What happened? So there are applications out there that use POP3 that do not delete the messages off the server. That's real world, but theoretically a POP3 server is going to delete those messages from the server after they've been downloaded. Now, if the user is static, if they use the same PC every single day to get their mail, then there's not going to be a problem with that. and that deletion prevents the email server from being overloaded. But if they're mobile, it does get to be a bit of a problem because, again, that email server is going to download the messages or allow the client to download and then delete them. And again, having worked in a situation where POP3 was deleting the messages off the email server, when people can't go back and get them later, they get furious. So one thing that does help out with that is IMAP. And let's talk about that for a moment. Again, just mentioning POP3 does run on port 110. And so what IMAP does for us, and that's Internet Message Access Protocol. As I mentioned, in today's networks, there are plenty of end users who are not going to check their email from the same machine every single day. Some offices actually have people go to different PCs every single day. They don't even sit in the same place. So a better solution for those users is IMAP. And the keywords there are message access, because that's what the end users actually have. When you access your messages on an IMAP server, they're not actually downloaded. You access them while they're on the server, and the messages themselves stay on the server, and they're not deleted by the server. Now, I did put right after that with a smiley face, you better use disk quotas. And those of you who have network admin experience know what I'm talking about, where on file servers you have to tie down a client, to, say everybody gets 100 mega space or everybody gets 150 mega space. Well, if you're using IMAP and you're not forcing some kind of email message deletion, I'm telling you from personal experience, you better enforce some kind of quota, because people will save emails. They go back 5 years if you let them, and they're just space hogs. They don't look like much by themselves, but when you get months and years worth, you've got to get people one way or the other to clear those messages out. So I do recommend you use disk quotas, or your email server is going to get real full real fast. Just a couple of notes here to wrap up the discussion of the email protocols. IMAP does run on port 143. Always know your port numbers before you take these exams. And the latest version is IMAP 4. So again, as we wrap up our discussion here of POP3 and of IMAP and of SMTP, I would, if I were you, take my learning far past this. I would actually get out there, learn an email application. I don't care if you set up a lab at home and play with it some there. Because obviously when you play with it at work, you tend to get fired, so don't do that. But the more you learn about email protocols, the better off you are. And we'll just wrap that up right there and go into a discussion of our web protocols, HTTP and HTTPS. Our next protocol you're certainly familiar with if you've ever spent any time on the internet. And if you've ever bought anything on the internet, you've probably used our second protocol as well, HTTP and HTTPS. And the Hypertext Transfer Protocol, very basically, it's the protocol that allows a host device to retrieve web pages from a web server, and that's on the ever-popular port 80. Because if ever on a firewall you have people who can't get to the net but need to, or can get to the net and you don't want them to, it's port 80 that you either have to open or block to allow and deny access to the web, respectively. Now, HTTP Secure, which is HTTPS, runs on port 443. And if you ever ordered anything online, as a matter of fact, you probably ordered this video course online, you used HTTPS but didn't even realize it, perhaps. Because when you put an item into a shopping cart online, or you're visiting, Train Signal or the BryantAdvantage.com, and you're just surfing around the site, you're using HTTP. But when you go to paying for the item on a secure site, or even in most cases now, even when you put the item in your shopping cart, you're using HTTP Secure. And the S on there, the secure part, indicates that there is now an extra layer of authentication and encryption between you and the site. Basically, we want to prevent the bad guys from just picking your phone number off the wire, or your credit card number, or any of your personal information that you put in when you're purchasing something online. And we can actually see that in action here. I'm going to bring up my favorite website, which just happens to be mine. I used Train Signals earlier, so we'll use mine for this one. And I just put it in an order button, and you can see right off the bat at http www.thebryantadvantage.com that there is no S in there yet. We're on port 80. We're using Hypertext Transfer Protocol. And when I hit an order button, and you can see it's opening page. You can even see that at the bottom what page it's opening. It says HTTPS. And note here that the S is now added to it. You're now on a secure connection to the shopping cart at my website. So at this point, when you go and you say, I want to continue shopping, or you want to go ahead and check out, when you hit the checkout button, all the information you put in there is secure. You don't see this in all browsers anymore, but you also see the little lock come on the bottom, and you can see it says SSL secured 128-bit. That's secure socket layer. And what you really want to look for, though, is that little letter S. If you don't see that, that means this information is not going to be encrypted, and that is not a good thing. Telnet and SSH, they do the same thing, but there's one big difference. They're both remote connectivity protocols. Both of these protocols offer the ability to connect to a remote device from a local device, whether it's a PC, it can actually be a router connecting to another router. And it allows you to work with the remote device as if you were physically there. And if in your network admin work you have not yet used Telnet or SSH, you will one day, I promise you that. So let's take a look at a typical scenario in network administration where you would need to use Telnet or SSH. Now here's one such scenario, and it doesn't have to be, there doesn't have to be an ocean between the PC and the router. It could be just a city. It could be on the other side of the city you're in right now. But let's say that you're in New York City, and a router that you need to change a configuration on is in Paris. And obviously that's a very wide area network that we've got between the two. Well, you got three choices here. You can either go to your favorite internet travel site and book a flight. You could call someone in Paris and walk them through the configuration and tell them what to do. Or you could use Telnet or SSH to connect remotely to the router. Now, unless you work for a particularly generous company, the first choice about booking the flight, that's probably out, right? But you could use the second option, but it's really clumsy sometimes to try to walk someone else through a configuration, whether it's on a router, whether it's on another PC. If you've ever done that before, you know it can be kind of tricky, and you're just better off if you can just do it yourself. And the better option here is to connect to that router. It's router by yourself and using either Telnet or SSH. Now, Telnet is an application layer protocol that runs on port 23. And I mentioned that Telnet runs at the application layer for a specific reason, because we use IP addresses to Telnet to a router. And it's easy to look at that and say, okay, we're putting in an IP address, therefore this must be a network layer protocol. It is not. Telnet is an application layer protocol. And you can Telnet from a PC to a router by using the command Telnet followed by the IP address of the device you want to connect to. Well, let's do a live demo there. Let's bring up a command window here, and we'll drop back a few layers just because I like to. And let's try telnetting to a router at 74.92.186.155. And it telnets to it, and notice it's asking us for a password. This particular device that I am telnetting to is a Cisco router, but almost every router or any device is going to be like this. By default, the other device has to be configured to allow you to telnet in, which is a real good idea, because you don't want people just telnetting to your PC without you letting them in, right? I mean, that would be a really bad idea. So here it's asking me for a password, and I'm just going to type a couple of bad passwords here. And after 3 attempts, Cisco router just says, hey, get out of here. You'll notice also a security feature with many routers today, that the cursor did not move when I was typing the password in. It didn't even show asterisks. So you need to get used to that. When you telnet to a router, you're not going to see the usual Windows thing where you see an asterisk come up for every character. The cursor doesn't even move. Security feature. So there we are. We can telnet to a router or another device, but telnet does have its drawbacks. And the biggest one is that it doesn't perform any kind of encryption by default, any data encryption. That includes the passwords. So if I entered the correct password there and someone was able to intercept the packets, they would be able to see the password just sitting there. And that's where Secure Shell comes in. And I mentioned on the fourth line down from the title, Secure Shell does have a default encryption scheme, and it runs on port 22. SSH does allow data encryption, and it has a lot of other features. Now, point blank, Telnet, to allow Telnet access, takes about 1 minute of planning. Really, I mean, you got to get the details right. You got to know where to put the password on the device, whether it's a router or a switch or a host device. But it really doesn't involve a great deal of planning. SSH does. It's not the easiest thing in the world to set up. I'm not saying it's incredibly hard, but it's a lot harder than just allowing Telnet. But I would tell you that while it does require more configuration and more planning than Telnet, it's well worth it. So again, the two port numbers right next to each other, SSH runs on port 22, Telnet runs on port 23. Telnet doesn't have any kind of default data encryption scheme. SSH does. That's why it's called Secure Shell. But again, SSH can be quite involved. So if you decide to implement it in your network, do not just jump into it. You know, do the due diligence, dig in, get your details, test it, and then roll it out. While we're on the subject of wide area networks, let's look at another protocol that is not a reachability protocol or a connectivity protocol, such as Telnet or SSH, but is actually a protocol that can be run over a wide area network and gives us several options for encryption and authentication. And that's the point-to-point protocol, much more commonly referred to as PPP. Now, a point-to-point connection in networking simply means that there are two and only two possible endpoints, which in turn means that from either endpoint's point of view, there's only one other possible endpoint. Now, if you're not confused yet, let's take a look at an illustration that'll help bring that home a bit. And this is a point-to-point connection in networking. I put ISDN there, which is Integrated Services Dial-Up Network. And that is a protocol that allows Cisco routers or any routers to connect over a WAN via a phone call. But this does not have to be ISDN to run PPP. It could just be a WAN connection of any kind. And here, though, as I mentioned, integrated services dial-up network connections, connection created over phone lines where one router literally calls the other. The reason I mention that is if you pick up the phone and you dial a number, then only the person who has that phone number can answer. If you call my cell phone number, then I'm the only person you can connect to. I am the only other possible endpoint for that call. That's a point-to-point connection. Well, here we've got two routers on a network and no others, and they're connecting through a WAN cloud. And this is a point-to-point connection. There's only one possible endpoint. From New York, the only way to go is to Paris, and from Paris, the only connection they can possibly make over this network is to New York. So this is a WAN connection, and we better have some kind of username, password authentication in place. Preferably, the password should be encrypted, although that's not always the case. But whether it's encrypted or unencrypted as far as the password goes, that's made possible by the point-to-point protocol, PPP. Now, when an interface is configured to use PPP, the remote device has to be configured for PPP as well. For many routers, the default protocol running is HDLC, High Data Link Control. If one side is running HDLC and the other side is running PPP, the two sides of the point-to-point connection, they're not going to be able to communicate. That has to match. And when we get into the point-to-point protocol, we've got three options for authentication. The password authentication protocol, or PAP, sends the password in clear text. It's a bad idea on wide area networks. The challenge handshake authentication protocol is going to send the password in a hashed format If you don't know what that is, I'll discuss it in just a moment and actually show you a password that has been hashed. Also, Microsoft Challenge Handshake Authentication Protocol obviously is Microsoft's proprietary version of CHAP, and it also sends a password in a hashed format. And before you say something like, oh, Microsoft, they got to have their own version of everything, you need to kind of get used to that in networking, because when you start working with Cisco, they've got some protocols, even some routing protocols, that only run on Cisco routers. If you send a routing update packet from a Cisco proprietary protocol to a non-Cisco router, it's not going to understand it. So vendors do tend to come up with their own versions of protocols and services from time to time, and you just kind of need to get used to that. But mostly what you're going to see on today's wide area networks are PAP and CHAP. And that's what we're going to talk about here, and we're also going to revisit these terms in the security protocols section. Now with PAP again, it does have a password. It does run an authentication process, but the password sent from one endpoint to another is in clear text. Here, I set the password computer for the PAP authentication, and Paris will authenticate New York with using the password computer. That is, Paris has to be expecting that password. But again, if someone manages to intercept these packets during the transmission and looks at the contents of them, the password computer is just going to be sitting right there, just like it's sitting right there on the diagram in front of us. So we don't really want that. That's not a good idea in today's wide area networks. So again, PAP, Password Authentication Protocol, does not encrypt the password in any way, and that's almost as bad as no authentication at all. Now, CHAP, on the other hand, and again, the full name is Challenge Handshake Authentication Protocol. It's much more secure than PAP is, because the actual password is never really passed out over the WAN. Because what happens is, one router is going to run what we call an algorithm. It's simply a mathematical formula against the contents of the password using a random number. We can't even say, hey, use number 17 when you're running this incredibly complicated algorithm. We can't even tell the router or the device to do that. So we really can't control what the result of the hash is going to be, which makes it a lot more difficult for someone to intercept the packet, see the hash result, and say, oh, okay, here's the password. Because it's going to look something like that. I'm going to show you a hash password in just a moment. And what happens is, that hash value and the random number are passed over the WAN, just as you see in the illustration. And the remote router is going to get that and run the algorithm in reverse using that random number and that hash result. And when it runs it in reverse, the password it comes up with has to match the password that is already set on, in this case, the Paris router, to allow New York to connect. Now, if that's a match, then the authentication is successful and the data transfer can begin. If it's unsuccessful, naturally, the connection is going to be dropped. And to show you what a hashed password looks like, let me bring up a Cisco router here. And here in the middle, where the white box is where I want you to pay special attention. This is beyond Network Plus, don't worry about this, but I want you to see it. On the BRI0 interface here, that's an interface for ISDN connections, and you can see in the second line of that interface configuration, I put encapsulation PPP, that's PPP encapsulation that we've been talking about, and then I put PPP authentication PAP. But what I did is I configured this router to hash the local password. So an unhashed password is going to look just like this. And here I've got the word Chiefs for a password incoming from another router. But I encrypted this password. This is the result of a hash algorithm being run against the word Packers. So if you could look at that string of numbers and letters and come up with the word Packers, kudos to you. I could not do that. There are applications out there that are supposed to be able to unencrypt hashed passwords, but I haven't seen very many that were really good at doing that. And also, it's going to come up with a different string, a different hash result every single time it's run, because that random number is always going to be different. We could run 5 different hashes against the password hackers and get the exact, get not the exact same thing every time. We're going to get a different result every time. The string will even be different lengths. So not only are we going to have different numbers and different letters, it's not even going to be the same size. So it's virtually impossible for anyone to look at this and run it in a program and say, okay, the password is Packers. So again, when it comes to these protocols, and we will revisit them when we talk about our security protocols, because they are indeed security protocols, while you need to know the differences between PAP and CHAP for your Network Plus exams, and certainly when you go on for your CCNA, you'll really need to know the differences. But you're really not going to see a lot of the password authentication protocol out there in today's real-world networks due to the lack of password encryption. That's asking for trouble today. So that's an example of PAP and CHAP. One common thread among network engineers, admins, whatever you want to call us, I mean, I personally don't care about titles as long as the check clears. We always feel this need to make fun of a company's name, or make a pun out of it. I don't know how many different names I've heard for Microsoft or any of their products, and of course most of them I can't repeat since the FCC may be listening. But one I've always remembered well, even though it's been quite a while since I actually had to work with the Windows Internet Name Service, WINS, is a networking colleague of mine used to say, when you wins, you lose. And WINS really isn't around much in today's networks. It's pretty much been replaced by Active Directory and DNS when Windows 2000 came out, but it was very big in Windows NT 4.0. And I haven't seen any of that in quite a while. Of course, Microsoft doesn't even support that particular operating system anymore. But believe it or not, there are very small NT 4.0 networks still out there. So we're going to discuss WINS here for just a moment, because your biggest nightmare when you ran a Windows NT network would be a user who said, well, I can't browse the neighborhood. And they meant network neighborhood by that, even though you could, and I always did, map drives for them. People always wanted to browse through network neighborhood to get where they wanted to go. And if it didn't work, it was probably a WINS issue. Now, what WINS actually did, or still does, is take a NetBIOS computer name and resolve that to an IP address. It does for NetBIOS computer names what DNS does for host names. And I put WINS and DNS up there next to each other so there wouldn't be any confusion. But if you have never worked with WINS, I'm going to be blunt with you, you didn't really miss anything fun. Very flaky little service in my humble opinion, and it can be very, very difficult to troubleshoot. And again, users who like to go through network neighborhood were often frustrated, which of course led to frustration on our part. So again, just to review very quickly, WINS does for NetBIOS computer names what DNS does for host names. That's really all you need to know about WINS. You're not going to have to set up any servers or anything like that on the exam, and hopefully not in any real-world networks either. Now, IGMP, the Internet Group Management Protocol, I've already put on the whiteboard what it does. And as you already know, whether this is your first training course with me or your third or your fifth, I'm fond of saying the name is the recipe. And I don't just say it to be cute, because it's not. But, I know from experience that when you're trying to learn what all these protocols do, especially, let's say, if this is the first time you've seen almost any of this stuff, or you just heard of it, you didn't know what it was, it can be overwhelming. I've been exactly where you are right now in your chair trying to learn all these protocols, and it'll drive you nuts at first. You're just trying to keep them all straight. And the one piece of advice I really want to give you about that is don't just memorize the acronym, DNS or DHCP, know what they stand for, not for an exam question per se, but if you have a question of your own, what does this protocol do? DNS, domain name service. Well, you take it from there, and you can usually figure out what they do, dynamic host configuration protocol. That almost always helps, but here it doesn't really help a whole lot. This is one you might just have to do a little memorization for at first, because the name is not the recipe. Internet Group Management Protocol. Well, it's managing a group, I'll definitely give you that. And it is a protocol, but it's really not descriptive beyond that point. You already know what a broadcast is. That's traffic that is destined for everyone. The destination is everybody. When a host device sends a broadcast, it sends it out there, and every single device that data can get to is going to look at it to see if they should read it. When we're talking about DHCP requests and discover messages, those were broadcasts. Well, a unicast is the other end of that spectrum. A unicast is traffic intended for only one host. Just as a unicycle has one wheel, a unicast has one destination host. Well, that's a pretty broad spectrum there. I think you'll agree. You know, one person or everybody. So we needed a middle ground there. And one was developed, and what that's called is a multicast. And a multicast is intended for some host devices, but not all of them. And the hosts that a multicast is intended for are referred to as members of a multicast group. And that's what we're managing here with IGMP. Now, IGMP, again, allows you to manage the members of the multicast group, and you may be thinking, well, you know, what can I relate that to? Unfortunately, nothing yet, because the actual management of a multicast group, the creation of a group, and the different versions of IGMP, that's way beyond the scope of Network Plus. Actually, it's even a little bit beyond CCNA, so unfortunately, it's not something that I can give you here as an extra. You'd have to know a little bit more about the switching for me to really show you how IGMP works. But I do urge you to do some more reading about IGMP and multicasting as a whole, because it's used commonly in today's networks. When you are going after your CCNA, you are going to bump into a lot of protocols, several protocols, I should say, that use multicast groups as their destinations instead of broadcasts. It does cut down on overall network resource usage. So again, IGMP, you know, just have the definition down at this point. It lets you manage the members of a multicast group, and you will learn more and more about multicasting as you progress on and earn other certifications. Now, there are a few non-TCP IP protocols that relate to the protocols that we have talked about in this video and the prior one. And these protocols run on Novell NetWare or AppleTalk. And that, of course, is the Mac operating system protocol. I'm going to mention them here to compare them to the protocols that we've covered here so far in these two videos. And I'm going to mention them again in the operating system section. So let's take a look at the first one. And here's a mouthful for you: the Internetwork Packet Exchange Sequenced Packet Exchange, IPX-SPX. And this is really Novell's equivalent of IP and TCP. And if you're thinking, well, I've seen Novell networks run on IP, they will run on IP as well. Novell's kind of given up the ghost as far as, you know, forcing people to use IPX if they're going to use their products. They had to adapt to that. But before we go on, I definitely want to say that Novell is hardly obsolete. I mean, I'm amazed that people mention Novell to and say, oh yeah, you know, Novell's dead. One thing you'll note in this field is that people are very quick to say that something is really hot or it's really dead and there's no in between. And that's just generally not really the case in the real world. Novell's not going anywhere. Depending on which statistic you read, Novell Directory Services is in use in over 80% of Fortune 1000 companies. And what Novell Directory Services is, NDS there, as I have it on the board, it's now known as eDirectory, but a lot of Novell gearheads, as they're called, will still refer to it as NDS, myself included. Actually, Novell was the first operating system I ever managed or worked on. So I'm a little bit of a Novell loyalist, and it's still a great product as far as I'm concerned, and it's hardly obsolete. But what I mentioned here to you, that's Novell's directory database, eDirectory, but it was called Novell Directory Services for such a long time. People still refer to it as NDS. And that's what you use in Novell to manage, delete, and add just about everything from a server to a user to a print queue. And eDirectory also performs NDS name resolution for Novell. So that's how Novell is going to have name resolution performed. And you need to take care here and not get NDS mixed up with NBP. And I know that we're in acronym heck here, but nothing I can do about it except prepare you for the exam. Let me get rid of that real quick so you can read that. There we go. So just a name resolution protocol comparison here for you. TCP/IP uses DNS for host-named IP address resolution. As I mentioned a few minutes ago, NetBIOS names are resolved to IP addresses by WINS. IPX/SPX uses NDS, Novell Directory Services, or eDirectory. You should be prepared for your exam to refer to it by either name for name resolution. And then finally, AppleTalk uses the Name Binding Protocol, NBP, for name resolution. So that's a good chart to keep straight, especially for your exam, because right now at the network level, one of the things we're most concerned about is how are host names or other names getting resolved to IP addresses. So certainly fair game for the exam, and I would definitely know those by heart. Here's a list of common port numbers that we've gone through here so far in the protocol video, so I thought I'd put them here for your reference. And also, I want to talk to you about these port numbers because, again, having been where you are in your studies and knowing what that's like, and you're faced with some things you just have to memorize, maybe you haven't gotten a lot of hands-on with it yet. And there's a temptation to ask yourself, well, besides passing the exam, do I really need to know this stuff? And I think that's true mostly of the OSI layers, the OSI model, and port numbers. And I'm telling you from my personal experience, and again, having asked myself that same question years ago, I can tell you the answer is yes, you need to know these port numbers. Because point blank, depending on your role, you're going to spend 80 to 90% of your time on the job troubleshooting. We don't go in the morning and install Cisco routers every day. We don't go in every day and install brand new email servers on a daily basis. We don't do any of that. What do? We're troubleshooting. We're taking care of a printer that someone can't connect to. We're getting somebody back on the internet who can't get there. We're taking care of somebody who can't get their email. Something like that. And the key here is to be an expert troubleshooter, and that's what you have to be to excel in this business. And I want you to take this course. I want you to go on. I want you to pass the Network Plus exam, and I want you to become a world-class troubleshooter. And part of that is knowing how things work when they're working correctly. If you look at something that's broken and you don't know what it's supposed to look like when it's fixed, when it's working properly, how can you fix it? You can't. This way, when things do go wrong, and they do, you can take a structured approach to fixing them. And we're going to talk about taking a structured approach to troubleshooting later in the course, because it really will help you greatly. But let's just take one example right now. Let's say that you're in the middle of a relaxed day, yeah, I know, at your network console. And you've got a consulting company at your site, and they're putting in a new firewall. And then all of a sudden, bam, you've got all these users calling you saying, I can't get email from outside the office. I can get it internally, but I'm not receiving any of my external mail. Personally, the first question I always ask myself when I'm troubleshooting, what has changed since what is now broken was working? That's the first question I ask myself. What just happened to make that break? Well, in this case, a firewall is being installed, but do you know why that would stop email? Do you know that ports 25 for SMTP, 110 for POP3, and 143 for IMAP have to remain open by that firewall? If you do, you already know how to fix the problem. Because I can tell you again from personal experience, the key to becoming a world-class network troubleshooter is mastering the basics. The most important study you'll ever do, you're doing right now. Network Plus, Security Plus, MCSE, CCNA, and I can say that as a CCIE. The most important study you'll ever do are all the fundamentals. And if you're a great network troubleshooter, frankly, you're always going to be in demand, and that's exactly where we want to be. So, that's the end of your dad lecture, but sincerely, having been there, having been faced with these things to memorize for an exam, I think, well, I don't really need to know this stuff. And years later, I can tell you, yeah, you really need to know this stuff, because I've seen people, who can troubleshoot and people who can't, and you can learn how to do it. You're not born knowing how to do it. But I've seen people who really know how things are operating, and they're the ones who can troubleshoot. I mean, if you don't know what ports FTP runs on, how can you begin to troubleshoot it? How could you even start? You got to have a reference point. We're going to take a few minutes here to review some of the high points of not only this particular video, but the previous one, because they all cover the network protocols that you need to know about for the exam and for real-world networks. And again, this is not a substitute for watching both videos. So when you're reviewing, try to make time to watch both videos in their entirety. But again, we do want to sum it up with a review here because there are just so many details here, especially if this material is new to you. We had quite a discussion about TCP and UDP, and just hitting the high points of that discussion. TCP has a large header, as you saw. It does offer error detection and recovery through the use of sequence numbers. It has windowing. Remember, by default, there's a 1-to-1 ratio between the number of segments that a host can transmit. Then it has to wait for an ACK before it can send another one. We can change that so it can send multiple segments without having to wait for an acknowledgement. And we call that windowing, and the number of segments that we can transmit without waiting for an ACK is the size of the window. TCP also offers guaranteed delivery. UDP has a very small header, if you recall, and it offers only best effort delivery. It doesn't have any of that other good stuff. No error detection, no error recovery, no windowing, no guaranteed delivery. But we use UDP because of the network overhead savings. The header being that much smaller does make it cheaper to our network resources to run than TCP. TCP is connection oriented, as you recall, with the three-way handshake, building an underlying control connection between the two hosts before segments are transmitted. UDP is connectionless, and naturally UDP doesn't need a three-way handshake. DNS, our domain name service, it resolves TCP IP host names to IP addresses. And I put this up here. This is a classic, and I've been through this many times. If an end user can reach a web server by IP address but not the host name, there is a name resolution issue. And what I like to do with a user who reports, I can't get to the internet, that can mean a lot of things. We all know that when you're working with end users, you have to use a little, of your detective skills. It's like Law and Order sometimes, to figure out what's really going on and what they're telling you. And if you can get the IP address of the web host, that web server that they can't reach, and you go into the browser and type HTTP, 2020 or whatever the IP address is, if you can reach it, then there's some kind of name resolution issue, and most likely it's a DNS issue. The command ipconfig all displays all DNS servers in use, both primary and secondary. DNS operates on port 53 in both TCP and UDP, the only protocol that does that of the ones we've discussed here, that is both a TCP protocol and a UDP protocol. And it also resolves fully qualified domain names, FQDNs, to IP addresses as well. You don't see FQDNs that often, and when you do, they tend to be incorrectly expressed, but it does resolve those. DHCP, we had quite a conversation about this. And DHCP, the Dynamic Host Configuration Protocol, it's the most popular of the two dynamic IP address assignment protocols, with reverse ARP being the other. Briefly, the DHCP process, the client is going to send a discover message. That's a broadcast. Every server that hears that discover message is going to respond with an offer of an IP address and a subnet mask. The client will accept the first offer it gets. It then sends a DHCP request requesting the rest of the pertinent information, but that also is a broadcast. The DHCP server that is going to give it the IP address does respond with the additional information in the DHCP acknowledgement. The longer the DHCP lease, the less DHCP-related broadcasts are on your network. As you can see here, we've got two broadcasts just with one host coming on the network. It's rare that DHCP broadcast will choke your network, but every little bit helps as far as broadcast production goes. DHCP broadcasts, like any other, will not cross a router. The router will accept it but not forward it. So a DHCP relay agent is needed where the client can reach it, where the client's broadcast will be seen by the relay agent. Never put the relay agent on the segment with the DHCP server. That doesn't serve any purpose. And DNS servers assign no layer 2 information. File transfer protocol, FTP server listens on port 21. An FTP client will request data and authenticate because FTP does have a username password. FTP server will then send data on local port 20 to the port requested by the client. So actually 2 ports are in use. The control connection is built on port 21 on the server, and the data connection is built on port 20. I don't have it on the board there, but just to mention, there is a TFTP, a trivial file transfer protocol, and that runs on port 69. There is no username password with TFTP. ICMP, the Internet Control Message Protocol, both pings and trace routes, or trace RTs, as you'll see them in Windows, are ICMP protocols. They detect errors, but they don't help you recover from them. That's up to you. Just a quick comparison of SMTP, POP3, and IMAP4. SMTP runs on port 25 and allows the transfer of email from one mail server to another. SMTP also allows clients to send mail to a server. SMTP uses MIME, those extensions, to allow graphics and audio to be inserted into email. POP3 runs on port 110 and is used by a client to download mail from a server. Typically, and not always, but typically, and the official theory of POP3 is that the server will delete that mail from the server after it's been downloaded. So while that helps keep the size of our email files down on the server, it tends to make mobile users very angry when they find that out. IMAP4 runs on port 143 and allows a client to read the mail from the server rather than downloading it. And the best part, as far as the client is concerned, it's not deleted afterwards. Just a quick comparison there of HTTP and HTTPS as far as the ports, and we saw what happens when you go to an e-commerce site and go to the shopping cart. We went to HTTPS. Telnet and Secure Shell, SSH, are remote connectivity protocols. Telnet running on port 23, SSH on port 22. SSH offers data encryption where Telnet does not, but it is more difficult to configure. PPP, the point-to-point protocol, offers PAP-CHAP and Microsoft CHAP as authentication protocols. PAP uses a clear text password, and CHAP and MS CHAP send a hash result and a random number. They do not send the password in clear text. WINS, our old friend, is for NetBIOS computer name to IP address resolution. The age-old statement, I can't navigate network neighborhood. I still hear one particular client from 10 years ago in my sleep sometimes saying that. That's a WINS issue. IGMP, as I mentioned, it's a multicast group membership protocol. A couple of other name resolution names here. IPX and SPX uses Novell Directory Services, NDS, currently known as eDirectory for name resolution, where AppleTalk uses NBP, the Name Binding Protocol. And just one more time, there's that list of port numbers for you. And it's a good solid list to know for your Network Plus exam and to get you started in your networking studies. You will learn many more port numbers. And the more experience you get, whether it's in a home lab that you set up or online or actually at work, we don't get to practice at work. Never practice configurations at work. But you'll be quite surprised the more you do with these port numbers and these protocols, the easier the port numbers come to you. So if you're struggling a little bit, trying to remember, okay, SMTP is port 25, that's going to come to you. So don't worry about that. Make sure you know this particular list for your exam. I would know this list for any networking exam. You're going to hear the term well-known port numbers occasionally, and that brings in all the port numbers from 1 through 1023. Don't worry, you do not have to know 1,000 port numbers to be a network administrator. I don't know 1,000 port numbers, but I would know these. It's a good solid foundation to get started with. So again, there's a lot of information here. We have covered a lot of ground in these 2 particular videos for the networking protocols. So take your time with it. Repeat the videos, as you need to. When you come back and repeat them, don't just watch the last few minutes of this one the first time. There's nothing wrong with using this as a review. That's why I have it here for you. But take it all in. We had a couple of live demos in these 2. Went into a little extra explanation on a couple of them when we might use them. and then just take this review in. You'll have all of them down on exam day. You'll have all the protocols down, and I have no doubt in my mind that you'll pass, and these two sections are pivotal to getting you to a pass. So thanks for your time. Hang in there. I know what it's like to try to memorize all these port numbers and remember all these protocols, but I am living proof you can do it. I know you can. Thanks for your time, and I'll see you on the next video.